Hey everybody. So this video here is going to be focusing on the physiology of our bones. That said, there is a lot going on in this video, so I'm not going to go in as much detail as I usually would with a lot of these topics. And also keep in mind this video is going to be a little bit longer because of the various components of the bones and their importance throughout the body. So that said, let's jump right into it. Start off right here at the top, the minerals of the bones. So as you can see, I do not have specific minerals in here. However, it is important to understand their functions throughout the body. And then with that said, they're used for a variety of things, such as maintaining your heartbeat, regulating your hormone regulations, as well as your growth. So that said, your bones are extremely important in that regard, specifically the minerals within them. Specifically, we could look at calcium and phosphorus. And again, keep this in mind with everything in this entire everything anatomy and physiology related. Everything is based on homeostasis, the balance of everything. So that said, phosphorus is extremely important and a few reasons why: repair of bones and teeth, muscle contractions, again, hormones, metabolism regulation, extremely important for those. Not only that, we have our calcium, which is important for, again, a multitude of things: blood clotting, hormone release, nerve signaling, muscle contractions. These are all extremely important things to keep in mind when we're looking at the minerals found within our bones. Having to do with the minerals, we need to discuss resorption. So, resorption is extremely important because this is the process in which your bones are broken down by those osteoclasts that we talked about and absorbed into the bloodstream. So, in other words, what? Why is this happening? So, if your body is in need of any of these minerals at any time, you have that storage within your bones. So your body will send a signal to your bones to release some of these minerals so that you can absorb it into your bloodstream and use it somewhere else. So again, think of your bones kind of like a bank, right? Every time you eat, every time you put into your body, specifically these minerals, once they go into your bloodstream, they're deposited, literally, same word to use with money, into your bones, kind of like a bank. And then we keep on depositing it over time. And every once in a while, whenever we need it, we can withdraw or resorb those minerals into your bloodstream so that you can use them somewhere else. That said, calcium and phosphorus homeostasis. So the skeleton serves as a reservoir. This is exactly what it said. It's going to serve as a reservoir or kind of like a bank for our calcium, phosphorus, as well as many other materials. All right. In an example of the importance here, we can see that calcium, if we have a low calcium concentrations, also known as hypocalcemia, again, hypo is low, calcemia, this is going to cause our nervous system to be a little extra excitable, hyper excitable. So muscle tetany can be something that results from this. We'll talk more about that in a little while. If you have too much calcium, you can have the opposite effect. So again, it's a little strange to think about, but the idea is the amount of calcium really does matter in the body. So our bones' ability to resorb that, as well as deposit that calcium amongst other minerals, is extremely important. Continuing here, we can discuss a few of the hormones that are needed in order to allow our calcium to store or be resorbed out into the bloodstream. So there are a couple of hormones that are important for this. The first one we're going to talk about is calcitonin. So calcitonin's job is to lower the blood levels of calcium. This is a great question here because it makes you have to think about what's going on. And this is a common theme we see within this class, is that people can memorize a lot of the terms and understand what they mean or think they understand what it means, but really they're just memorizing the term and they know what it means. So it doesn't mean they understand what it does, they just know what the word means. Example, calcitonin. Job, lower blood levels of calcium in the body. So does that mean they are stimulating osteoblasts and inhibiting osteoclasts? So activating osteoblasts and slowing down osteoclasts from doing their jobs? Or the opposite? Right? It's a good question. With that said, the answer is it's going to stimulate the osteoblasts and inhibit the osteoclasts. Again, to lower your blood levels of calcium, that means you have to store it somewhere outside of your blood. Right? We're lowering the blood levels. So that said, you want to put it in your bones. How do you put it in your bones? You need to stimulate bone growth. Those are the osteoblasts. Also, you're going to inhibit the breakdown of bone, which makes sense. You don't want to do the opposite. That's inhibiting the osteoclast. So this is just a great example to get you guys thinking about how the hormones work in the body, as well as the types of questions you should be able to better understand. It's not just memorizing words. It is going above and beyond and applying it into things like this. Next up is parathyroid hormone, or PTH. It does the opposite. Okay, so its job is to raise the blood calcium level, and to do so, it's going to have to stimulate the osteoclasts because they're going to break down the bone and allow for additional resorption. It's going to do other things too. It's going to make sure that we lessen our urinary excretion of calcium, right? If we need it in our blood, do we really want to pee it out? And then also stimulate vitamin D synthesis. So these are all really important things to keep in mind when we're talking about homeostasis, when we're talking about bones, and when we're talking about just all of these things put together, application. And here is the last slide to discuss. Here is a great example of one of the feedback loops of maintaining calcium and phosphorus within our bones and within the body. Again, this is a negative feedback loop. Take a minute, take a look at this, and if you have any questions, we could definitely discuss this in class. So please reach out if you have any questions.